print for Suspended T version 3.12. So let's review how to read a print by looking at this one. So there's a lot going on here and it's very complicated, and visually this can just be like, oh, what's going on? So in that case, what we want to do is let's follow a set of practices for understanding reading a print, and every print is laid out the same way. At the very bottom, we're going to find the title box. And this print, the title box, is a bar that occupies the entire lower part right down here. And you're always going to find the same kind of information. It may not look exactly like this, but every print should have some things which help us understand what we're looking at and how to read it. So the first thing is the name of the company that did the print, or belongs to, in this case, welding and fabrication here. The name of the object, which is Suspended T version 3.12. Who drew it? What's it made out of? The date it was drawn over here. And very important is our tolerances. Now, the tolerances are how far different can our part be from the specified measurements before we get into trouble. So on this print, it's telling us fraction-wise plus or minus 1/16. So let's say right here, this 5 inches right here. That means this distance can be either 5 and a 16th, or it could be 4 and 15 sixteenths. Anywhere between those two measurements is acceptable. Same thing with angles. And if there are any decimals present, which there are right over here, this is the plus or minus 0.0625 inches that is permissible. Next to it is revisions. Now, the revisions is a very important category which lays out for us changes that have been made in the history of the print. So over here is the month, day, and year that these changes happened, and notes on what was changed. This is very important, keeping track of how this part has evolved, changed, and modified since it was originally drawn. And it's an important thing to check this and see that, hey, if there's a change here, is it reflected on the print, or did maybe somebody forget something? So make sure you check this. Don't just gloss over it. Next to it, third angle projection. Not every print has this, but prints can be oriented in a couple of different ways. In the United States, third angle projection is the way things are done here, and you can see the way this object is arranged kind of reflects the way the front and right side view are done. And first angle projection is reversed, where you're going to have a left side view and then a front view. So in Europe, this is common. You wouldn't have a right side view, but you have a left side view. So if you're working in a business that does work with companies in Europe, you may run into prints like this. You want to be very careful that you don't get confused about what you're seeing. So this is a very helpful little cartoon that helps you orient your mind to what you're seeing in front of you. Next, we want to check about, say if it's present, the bill of materials. So over here, the bill of materials, or it could be called a parts list. Think of it like a shopping list, the things you need in order to build the Suspended T. And here's a list of the parts numbered 1 through 6, the description, flange, tube, internal gusset, top plates, side plates, fins, material, which is the material condition or dimension. So here it lays out what the dimensions of the individual parts are. Now, yeah, they're on the print, but over here, they're made a little bit more explicit. And over here is the quantity of each one you need. 2 of number 1, 2 of 2, 1 of 3, 1 of 4, 3 of 5, and 3 of 6. Now, the material dimensions are given here. This is because the raw parts that you have to work with may not necessarily be in their final dimension. You don't want to assume that the pile of parts that you're picking from are the correct dimension. In many cases, you're building this thing from a sheet of uncut 4x8 plate and bar and tubes that you're going to have to cut down to the correct sizes, or they could be drops, or they could be leftover parts perhaps that you're drawing from, and you need to cut them, shape them, bring them to the specified dimension. So as part of this build, make sure you check all your parts very, very carefully to make sure that they are the correct dimension, because some of them may not be, and you're going to have to cut them to the correct size. So don't assume they are right. They may be not. Next is notes. Notes can be anywhere on the print, but they will be labeled notes. And over here, let's read and see what you have to do. So the notes are, think of it like rules. They're rules laid out by the person who commissioned the job. And these are things they want you to follow, things to keep note of during the build. So first, all parts must be approved after tacking. So this means that once you have measured your parts, you've prepared them, you've checked your print, and now you've tacked all your parts together as specified on the print, you need to have it inspected by myself or another faculty member so that we can look over it, make sure it's correct, and then approve you to move forward. And that would be number 2, welding process. Now the welding process on this build is to be determined by instructor. So it could be TIG welded, it could be stick welded, it could be MIG welded, or it could be a combination of all 3. And these we will lay out for you. And like any job, if that's what's specified, the welding process, welding wire is supposed to use, you need to stick with that. 3, sub-assemblies may be used. Now, this is something we're going to try out, where sometimes on a very, very large build, it's easier to build smaller parts with larger build and then put them all together at final assembly. Sometimes this allows easier access to certain parts that may be blocked or obscured if other parts are welded in place. Welding may be easier, but it's also worth remembering that sometimes by subassembling parts, you may cause problems. It may restrict access to certain areas that you cannot get to. So it's something that needs to be looked at very, very carefully. And like many parts of fabrication, this is not laid out in the print. This is understood as something that you need to figure out and derive by looking at the print and thinking very carefully about it. Part must be inspected after final assembly. So if you do use sub-assemblies and you get them all together in a proper configuration, again, this must be inspected by myself or another faculty member before you are approved to weld it out. And the welding of this says in number 5, part must be welded out in fixed position. This means that I will determine the position that you're going to weld this part out. And once it's been determined, the part may not be moved. Now, of course, you can put it away when we have to end class, but when you come back, you must return the part back into that orientation. So it's very helpful to take a picture or maybe sketch it out on the table where it's going to go. So you must return it back to that position and weld it out without moving it. This is to simulate working in a real world condition where a part is fixed in its orientation, and you must put your body into the proper orientation in relation to the part in order to weld it out. So yeah, it's a bit of a challenge here. Okay, so we've got our title box, bill of materials, our notes. Let's look at the print itself. So what kind of views do we have here? So we have a front view here, we have the right side view, and above it our top view. And off over to the right, we have another view, but it's not. This is a detail, and this is a detail of specifically of the flange. Now, it's very important to note that all the details will be explicitly labeled detail, so there's no confusion here. And these are done to just clarify small details that may be hard to make out on a print, or in this case, the flange detail is laid out so that the flange itself can be cut out on the CNC plasma easily without having to hunt through on the print. So that's why it's laid out here, just to make manufacturing a little simpler. So looking at our different views here, you may notice that there are callouts on here. Part 1 and the leader line leading to the part. This corresponds to our bill of materials over here. So we have 6 parts. There's part 1, part 2, part 3, another part 3. Here's a part 4, here's a part 5, and we also have part 6, which is right over here, pointing to the fins. So not every print's going to have that. Sometimes it does to make things a little easier. Next, we have our dimensions. So on the print, you can see right here is a 3-inch dimension for the tube. You go over here, tube, it is 3 inches long. Now, if the tubes you have are not 3 inches long, if they're, say, 3 and the 16th of an inch, hey, it's within our tolerances, so we can still use it. But if it's 3 1/4 or 3 1/2, then that part needs to be cut to bring it to the proper dimension. So check that carefully. Here we have, this part is to be 4 inches wide right here. This one is 5 inches high over here. Here's 3 inches. That's the length of the internal gusset. We have over here another 4 inches right there. Now, it's important to note when you look at this, these are the dimensions of the parts. These aren't overall dimensions, but they're dimensions of the part itself. And all of these corners are outside cabinet corners. Now, this is going to make fixturing the part a little bit more challenging, but outside cabinet corners like that are a very, very common type of weld where a part needs to have a very airtight or watertight joint. And it also leaves a nicely rounded corner that is, looks very attractive. So it's a nice way to finish up parts, but properly fitting it together is pretty challenging because your parts are basically balancing on a very, very, very tiny edge right here. So care must be taken with this kind of fixturing. We have our weld information, our weld symbols right here. And in the weld symbols, you notice many of them have TYP on them. Now, this is a shorthand that stands for typical. And the reason this is done is because if every single weld joint had to be called out, this print would be incredibly cluttered with weld symbols all over the place and would make reading it extremely difficult. So it's very common in prints where you have similar features all over the same object to say typical, which means, say in this case of this double fillet joint here, every feature exactly like this one, which is a corner like that, you're going to follow the same instruction. Over here, this is pointing to this one gusset, and this staggered weld right here means that for every single fin, because they're all the same, you're going to be following the same weld instruction. Down over here, typical fillet pointing to the underside of the flange means that this is an all the way around weld that you're doing here, over here, okay, and here. Well, actually, there's 2 of them. So you're going to be doing the same thing on all the flanges. Same thing over here on the inside of the flange and on the base of the tube right there. This one does not have a typical, but it's pointing to the inside part right here, the gusset, double fillet on both sides, pretty self-explanatory. So the weld symbols are not terribly complicated, but it's important to keep in mind what they're telling you. Now notice, some of these do have dimensional specifications on them, but many of them don't. Now in the case on the print where you do not have a specified dimension, remember, your weld cannot be the legs of your weld cannot be any larger than the thickness of the material you're welding. So say, hey, what size here? This is part 5, and if I go over here, it's a side plate, and these are all 3/8 of an inch thick, which means my welds can be no larger than 3/8 of an inch. So very helpful. Over here, pointing to the underside of the flange, our flange right here is 1/4 of an inch thick, which means this is a 1/4 inch weld. It can be no bigger than 1/4 of an inch. So these are helpful things that in looking at the print, Even though it isn't explicitly specified welding information, it is still there for us to glean from the measurements. The print also has center lines running through the part. Now, this is important because this tells you that when you're laying out the parts on the bench or the table, you need to follow these center lines on the actual parts themselves. So these center lines are passing through the holes in the flange this way and this way. So when you're laying out the parts, putting a chalk line, a Sharpie line, or a scribe line on the parts where the center lines are can be extremely helpful when you're fixturing them so that things are aligned correctly. Here, these dashed lines are the hidden lines, which show us features that are not visible on the surface. They're either behind or inside. So in the case of this flange right here, this is actually on the other opposite side of the part. It is not on the surface. Likewise, the gusset right here is on the inside of the part. It is not on the surface. Now, it may seem obvious right here, but sometimes the printing is not the best, or if you're working in a real hurry, it can be very, very easy to accidentally weld things on the wrong side and looking at the print assuming that you're correct. So please be careful about this. Okay? One final thing we have here, right here, we have this little A right there, which is a datum symbol from geometric dimensions and tolerancing. So in this case, the A is telling you that this bottom surface right here is a datum surface. Now, how does this help us in fabrication? So the A is, your datums are laid out in order of importance, A, B, C, D. So A is your primary, most important one, which means that this bottom surface down here is important and that your dimensions should be taken from this particular surface. And that, well, this is a great place to rest your part on the table. Your tabletop is your surface of record, your datum surface we're building on. So if you place this part on your datum surface A on the table and build from there, it'll go a long way to keeping your parts in proper orientation. If we had a B and C on this print, these would represent two more planes at 90 degrees to the plane A, and that would essentially define the corner. So this is actually very helpful for fabrication. Even though it is primarily used by machinists, we can use the same information for our benefit. Lastly, I've included on this print in the corner a QR code, which if you open it up on your phone or mobile device, this is going to take you to a three-dimensional model of this object that you can manipulate and turn around, rotate, and enlarge to get a better view of the joints, of the construction, especially the inside. So hopefully this will help things out. So that is just a quick run through of what this print looks like. Hopefully this will help you out.